Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Matrices. Topic: Addition, multiplication and scalar multiplication of matrices. Simple properties of addition, multiplication and scalar multiplication. Non-commutativity of multiplication of matrices and existence of non-zero matrices whose product is the zero matrix. Square matrices of order 2. Exercise 3.2. Addition of matrices. When are two matrices said to be conformable for addition? Matrix ani karamba matamda tinsinaba yagani. Two matrices are said to be conformable for addition if they have same order. Matrix ani tinsinaba yahange hairabadi same order oigadabani. Addition of matrices. The sum of two matrices of the same order is a matrix obtained by adding the corresponding elements of the given matrices. Matrix ani tinsinaba haibasi order manaba matrix ani dugi corresponding elements singdu tinsinaraga phangba matrix aduni. In general, if a matrix equal to Aij and B matrix equal to Bij are matrices of the same order, say M by N, then the sum of the two matrices A and B is defined as a matrix C whose elements is C suffix ij. Order is also M by N, where Cij is given by Aij plus Bij for all I and J. Corresponding elements sing tinsinaraga phangi hanagi matrix singduga order managadabani and denoted by A plus B. This is addition of A and B is denoted by A plus B. For example, A matrix is this, B matrix is this. Their sum is 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, 4 plus 8 is 12. Properties of matrix addition. Commutative law. If A and B are two matrices of the same order, then A plus B equal to B plus A. Matrix addition is independent of order. There is grouping ahan akongi makha ponde A plus B ga B plus A ga managani. Associative law. For any three matrices A, B, C of the same order, then A plus B of plus C equal to A plus B plus C. A plus B adding toraba matungda C hapsin baga A plus of B plus C ani sigi addition ga managani. Grouping ge makha ponde haveni. Existence of additive identity. Let A be an M by N matrix and O be an M by N zero matrix. Then A plus O equal to O plus A equal to A. Any matrix ka O ga haiba O matrix asiga zero matrix asiga tinsinarabadi any matrix type. Here O is the additive identity for matrix addition. O asidi additive identity for matrix addition. Matrix addition ki tinsinabagi identity element kawe. Existence of additive inverse. Tinsinabagi inverse. Let A be any matrix, then there exists a matrix minus A whose element is minus Aij. Order is also M by N, such that A plus of minus A equal to minus A plus A equal to O. Matrix ani si tinsinaraga matam punamakta O tarabadi zero matrix tarabadi matrix ani se minus A additive inverse kawe. Here minus A is the additive inverse of A or negative of A. Multiplication of a matrix by a scalar. Scalar mana matrix the puriba. Let if A equal to Aij, order is M by N is a matrix and small k is a scalar, then Ka is a matrix of order M by N which is obtained by multiplying its element of A by the scalar K. एक element खुदुंगमक तो k na puriraga phangma matrix to bu ka masibu scalar multiple of the matrix A by k kawi. Thus, K is equal to K times of Aij. K sina mapanda lebasi manung sang khani manung element pumna makta purirani. Assume order the remains unchanged. Example, thrice A, 3 na matrix A da puri rabadi, 3 na manung element, 3 na 1 na puri radi, 3 na 2 da puri radi, 6, 3 na 3 da puri radi, 9, 3 na 4 da puri radi, 12, 3 na 5 da puri rabadi, 15, 3 na 6 da puri rabadi, 18. Properties of scalar multiplication of a matrix. If A and B are two matrices of the same order, say M by N, and K and L are scalars, then number 1, K times of A plus B is equal to K times of matrix A plus K times of matrix B. Property 2, K plus L times of A is equal to KA plus LA. Negative of a matrix. The negative of a matrix A is denoted by minus A. We define minus A. Negative of A is denoted by minus A and is equal to minus 1 times of A. A matrix ta minus 1 na scalar minus 1 jina puri raga phangi. Example A is this: if minus A is manung element purna makta minus 1 na puri radi, first row this, second row becomes this. Difference of matrices or subtraction of two matrices. If A equal to this and B equal to Bij are two matrices of the same order, say M by N, then the difference A minus B is defined as a matrix C whose element is Cij. Order is also M by N, where Cij is equal to Aij minus Bij for all values of I and Z. A minus B have C A dagi B subtract over. Subtraction of matrices haragasu khanai matrix ani khaidonaba yage harabadi same order oigadabane. Also, A minus B is defined as A plus of minus times of B. A dagi B khaido C A plus addition of A plus minus B, that is minus times of minus 1 times of B. Ani addition ga sudi manayane define to way. Example, A minus B is this: 1 dagi 5 khaido 1 minus 5, 2 dagi 6 khaido 2 minus 6, 3 dagi 7 khaido 3 minus 7, 4 dagi I khaido 4 minus I, that is minus 4 minus 4 minus 4 minus 4, so on. Multiplication of matrices. Matrix Purinaba. When is a matrix A said to be conformable for multiplication with another matrix B? A matrix na B matrix na multiplied over C karama matamda yagadage. A matrix A is said to be conformable with another matrix B if the number of columns of A is equal to the number of rows of B. A matrix na B da puri basi product ABC defined to ge harabadi A gi number of column masinga ani suba matrix B gi number of row masinga managadabani. Multiplication of matrices. Let A equal to Aij, B and M by N matrix and B equal to Bjk. B and N by P matrix. N by P matrix ni khangjing gadabadi asai gina A gina Aij oibani hauji B gi di Jk oirani. Maramdi repeated suffix J se from the amok hanjalakani. I corresponds to M ni J corresponds to A ni. Adu J corresponds to the N oikibarina so J corresponds to N orani. Anova suffix K asigi the atopa later ama season nagani. Masi khangjin gadabani. Then the product AB of the matrices A and B is the matrix C whose element is C suffix Ik. Order is M by P, where Cik is AI1 AI1 B1K plus AI2 B2K plus dot dot plus AIN into BNK, which is equal to summation of Aij into Bjk. Summation is varying from J equal to 1 to N. J do na repeated suffix ta summation si logani. Example AB matrix 2 by 2 matrix ani si puri si karam na phangbagi yeng si first row gi 1 2 na first column da puri ra o 1 2 na first column da 1 ga 5 ka puri na 5 plus 2 ga 7 ka puri na di 14. Assume na first row na first column da puri ra 1 na 6 da puri di 6 plus 2 na I da puri di 16. Assume na first row na first column, second column do new first row gi limit ani si phange. Second row asina first column the second column the new second column phangadabni. first second row sina first column the puri si 3 into 5 d 15 plus 4 into 7 d 28 asumna second row sina second column the puri rabadi 3 into 6 the 18 plus 4 into it 32 ni sum up to rabadi si pange so the matrix multiplication si yamna haigadabani example 2xy 3 by 3 matrix sama puri re first row sina first column the puri ra first row na first column the puri di 1 into minus 1 plus 2 into 0 that is 0 plus 3 into 2 is 6 1 minus 1 plus 65 lairani asumna first row na first second column the puri rabadi 1 into 1 plus 2 into minus 1 minus 2 1 minus 2 the minus 1 3 into 3 the 9 9 minus 1 the 9 minus 1 d 3 into 4 1 minus 1 the puri rabadi 1 puri di 1 assume na 2 na minus 2 the puri minus 2 1 minus 1 and 3 na 3 the puri 9 9 dagi ekoi na kano khaidu obadi assume na sig number sing si pangani properties of multiplication of matrices matrix multiplication ki property kara commutative law for any two matrices A and B, product AB does not equal to product BA in general. Sometimes it is equal, in general it is not equal. Matrix multiplication see product AB ga BA ga in general in the manner de adano commutative law holds to day. The associative law for any three matrices A, B and C, product AB into C equal to A times of product BC. Associative property holds matrix multiplication the associative law holds name. The distributive law for any three matrices A, B and C, property 1 the A times of B plus C is equal to AB product AB plus product AC. A plus B times of C is equal to product AC plus product BC. The existence of multiplicative identity puribagi identity remain leiba. For every square matrix A, there exists an identity matrix I of the same order such that IA equal to AI equal to A. A have a any square matrix ni assume mahak order manaba I have a sina identity matrix haigani same order oigadabani babani si product IA sina equal to AI ga equal to IA tarabadi I asibu aikoina karikawi existed a multiplicative identity remain kawi. Non-commutativity of multiplication of matrices. Matrix purinabasigi commutative law holds oidaba. If AB product AB and BA are both defined, animak defined tawrabasu, it is not necessary that AB equal to BA. Product AB ga BA ga defined tawrabasu, AB ga BA ga managani have laite, mabani managani have laite. Example product AB matrix anisi purinarasi we get this phangane asumna BAB na mamang thango in tung thango product pang to hoji element anisi manadre matrix anisi manadre same order ujarabasu corresponding element manadre asumna product AB ga BA ga animak defined torobasu mabani managani haiba leite manar order manadabasu order manadabasu yai order manajaragasu corresponding manadrabadi manade. Therefore, product AB does not equal to product BA. The multiplication of diagonal matrices of same order is commutative. Diagonal matrice same order की diagonal matrices की product multiplication is commutative OI. Give reasons that matrix multiplication is not always commutative. Matrix purinabasi matam punamakta commutative OI de maram sing piu. The reasons are as follows. Number 1, reason 1, if product AB is defined but it is not necessary that BA is defined. Product AB defined tawraga BA defined tawgani haiba leite. Defined tawba amaga defined tawba ama manabagi wafam hangba yade. Result number 2, if AB and BA both are defined, it is not necessary that they have same order. Product AB amasung BA animak defined tawjaraba sumabani order managani have leite order manadrabadi manararoi. If product AB and BA are defined and are of the same order mabani mag defined tawraga order sumanaraba, it is not necessary that they are equal mabani managani have leite order manaja animak defined tawra order manaro corresponding element manadrabadi manade. Zero matrix is the product of two non-zero matrices. Zero nataba matrix ani puri naraga zero matrix tabayai. If the product of two matrices is a zero matrix, matrix ani ki puri nabadu zero matrix phanglabadi, it is not necessary that one of the matrices is a zero matrix. Matrix ani du ki manungda ama zero oigani haibasi higher ama zero matrix oigani haiba leite. Zero matrix nataba ani puri naraga zero matrix tabasu yai. Example, let A and B this matrix ani silore 2 by 2 ki matrix ani silore, then product AB is this zero matrix pange. Thus A matrix does not equal to zero matrix, B matrix does not equal to zero matrix, but their product is zero matrix. Asumna zero nataba matrix ani ki product to zero pange. Find two non-zero matrices such that their product is a zero matrix. Non-zero or prove that the product of two non-zero matrices is a zero matrix. Zero nataba matrix ani ke product si zero matrix ni prove to. Same as example of 14 above. Exercise 3.2. Let A equal to this, B matrix equal to this, C matrix equal to this. For the find is of the following: A plus B, A minus B, tries A minus C, product AB, product BA. Let us find out. Product AB 2 plus 1. 2 go 1 ka tinsinarani, plus 4 ka 3 ka tinsinarani, plus 3 plus of minus 2 we get this. 3 plus 5 we get 2 plus 5 equal to this. We get 3, this is 7, this is 1, this is 7. Also the matrix tinsinagani khaidok na badi 2 minus 1. 2 minus 1, 4 minus 3, 3 minus of minus 2 plus 2. 2 minus 5, we get 1, 1, 5 minus 3. Tries A minus C, tries A. Scalar na ahan matrix to multiply toro, we get this. Matrix ani sa mo khaidok na si 6 minus of minus 2 di 8 ni. 12 minus 5 di 7 ni. 9 minus 3 di 6 ni. 6 minus 4 di 2 ni. Product AB matrix ani se puri na si first row na first column da puri si we get 2 into 1 di 2 ni plus 4 minus 2 di minus 4 into minus 2 di minus 8 plus of minus 8 minus 8. Assume na first row na second column da puri si 2 into 3 di 6 lerani, 4 into 5 di 20 lerani. Second row si na first column da puri di 3 into 1 is 3 plus 2 into minus 2 is minus 4 plus of minus 4 di minus 4. Assume na 3 second row sina second column the puri 3 into 3 9 plus 2 into 5 is 10. We get what? Minus 6 26 minus 1 19. Assume na phangani. Product BA so hujikito ka chap manaba procedure da pang thokani. First row na first column second column the puri raga new first row phange. Second row na first column second column the puri raga new second row phange. Sum up torobadi we get this. Compute the following matrix in C. Edison put bani. C amelare A gatinade twice A B gatinade twice B minus B gatinade 0 A gatinade twice A. Sumna Roman number 2 matrix ani si tinjinau bani. Adu di tinjinarabadi A square plus B square plus twice AB. Asumna second tinjinar we get this. C ga tinjinari we get this. C ga tinjinari we get this. Formula parabani asumna pape square same. For Roman number 3 corresponding minus 1 or 12 to the 11 lere 4 plus 7 the 11 lere minus 6 plus 6 the 0 lere. So now I is 16 5 plus 0 the 5 16 plus 5 21 2 plus 3 the 5 I plus 2 the 10 5 plus 49. Roman number 4 corresponding cos square x plus sin square x. Sin square x plus cos square x. Sin square x into cos plus cos square x. Cos square x plus sin square x is being equal to 1. Makoi kudimok 1 ga manari. Compute the indicated products. Makado taiba karusu a production chipang to haven. First row na first column the purity we get this. First row na second column elements purinaraga sum up toradi we get this. Assume the second row na first column the puri row we get this. Second row na third column ki corresponding element na purinar sum up toro we get this. Ahan bagis the length na lene akon bagis the 0 lere si 0 lere si lere. Assume na Roman number 2 section gadaba amadi first row na first column second column third column. First row ki element 1 sina first column second column third column the 1 sina puri 1 into 2 di 2 lerani mathang no 1 into 3 di 3 lerani 1 into 4 di puri 4 lerani asum na 2 na amuk first column second column puri di 2 into 2 di 4 lere 2 into 3 di 6 lere 2 into 4 di 8 lere 3 na amuk puri ro 3 na 2 di puri 6 3 na 3 di puri di 9 3 na 4 puri 12 Roman number 3 2 matrix ani se number of column masing number of column masing 2 ni number of row masing 2 ni multiplication product is conformable defined the first row na first column second column third column we get new first row phangani second row sina first column second column third column the purity we get this sum up torabadi we get this asi phangi Roman number 4 first row na first column the second column the third column the purity new first row phangi second row na first column second column third column the purity new second row phangi third row sina first column second column third column the purity we get this sum up toragas masi phangani number 5 first row na first column second column third column the purity new first row second row na first column second column third column the purity new second row third row na first column second column third column the purity sum up toro this sum up torabadi symmetric asi phange asumna Roman number 6 so first row na first column the purity new first row na second column the purity new second first row na first column second column the purity new first row elements sing phangani second row sina first column second column the purity new second row value sing asi sum up torabadi according to 2 by 2 gi matrix asi phange if for that if a equal to this b equal to this the 3 by 3 matrix ngakani c su then compute a plus b minus c also verify that a plus of b minus c equal to a plus b minus c manai ulu haibane and whether a plus b putoxi Edison di amalare corresponding tinsinagani 1 ga 3 ga adding taro we get 4 2 ga minus 1 ga sum up toro 1 asum nate sing su putok lani b minus c su puton b di c khaidok pani 3 minus 4 di minus 1 ni minus 1 di minus 2 lerani 2 minus 2 di 0 lere asum na atai row sing su puto ani therefore a plus of b minus c a gi value pirani b minus c gi matak ta phangi value pir adi c adding toro badi c phange a plus of b minus a plus b gi value matak ta puto kare first one sin lo minus irani c gi value do sinjalani ani se khaidok na row we get this phangi base first row second row second third row manare therefore a plus b minus c equal to a plus of b minus c is verified chumi ule if a is equal to this b is equal to this then compute thrice a minus 5b thrice a minus 5b 3 na ahan by a matrix element iro minus 5 iraga b matrix element sing iro scalar 3 sin manung element pum na mokto puri 3 into 2 by 3 di 3 2 phangani 3 into 3 into 1 di 3 phangani 3 into 5 by 3 di 5 phangani 3 into 1 by 3 di 1 phangani 3 into 2 by 3 di 2 phangani 3 into 4 by 3 di 4 phangani 3 into 7 by 3 di 7 phangani 3 into 2 di 6 phangani 3 into 2 by 3 di 2 phangani asumna partner puri rabadi we get this ani je khaidok na rabadi we get this matrix simplify the question number 6 cos theta na manung element form na mokta puri ro cos square theta learning ka jodi sin theta cos theta sida puri minus cos theta sin theta sida puri cos square theta sin theta na manung da puri sin square theta minus sin theta cos theta sin theta na puri sin theta cos theta sin theta na sin theta da puri sin square theta ani is corresponding cos square theta plus sin square theta di 1 ni ani is sum up to di 0 ni ani is sum up to di 0 ni ani is sum up to di 1 find x and y if Roman number 1 x plus y is this x minus y is matrix ani si tinsinara si phangi ani sa khaidona si phangi x ama y matrix ani si putoibani matrix equation kawe asigi matrix equation and say y mang na bagi damakta di adding torus equation and si vertically adding torus we get twice x ani si adding torabadi si phange ani si sum up toradi si phangani 2 na muk divide to thokra left to na divide to the x phange 2 na divide to the half na puri baga chap mane half se manung de loina puri rabadi we get this assume x phange phangai bi s ki value say also y kadam bada s ki value pisal si y ki value equation 1 da si equation 1 si da s y ki value putoke di sigi sima irani minus x x ki value pisilo hojik to phang ki bu kaidok na raga asumna y phangani x amasung y. Find x if y equal to this twice x plus y equal to this 2 by 2 matrix sing mana rabadi y is given twice x plus y is also given zik y ki value y na sumna lepa thanga ga y ki value to pisilo kaidok na radi we get 2 by 2 matrix sama phange x putoke di 2 na divide toro manung element pon makta 2 na divide toro di we get this hojik x putokolore. Question number 7. Find x and y if Roman number twice x plus 3y equal to 2 by 2 and thrice x plus twice y equal to this. Matrix equation is sisu equation is 1 2 tholasi equation 1. Adudi hojik ahan bada y mangan si equation 1 da 2 na puri ro equation 1 da 2 na puri ro adu equation 2 da na 3 na puri ro y adu ka subtract torobadi the 2 na puri ro badi 4x the 3 na puri di minus 9 x assume see the 2 no puri we get this see the 3 no puri we get this subtract or see pang so no see the minus 5x is this x putoke di minus 5 na tang ko mo pi yellow we get this x pang abadi equation 1 da sinjilo x ki value adu thrice y ahamba do putoni assume no pang sini x ki value ni simplify toraga see pangani y putoke di 3 na the loni yellow 3 na yellow abadi we the 3 na yellow abadi we get this. Question number 9. Find a small x and small y if 2 times of 2 by 2 matrix plus 2 by 2 matrix equal to 2 by 2 matrix. Matrix equation number pyramid 2 na manung element pum na makto puri ro aduga ani si left to left ani si adding tawrani corresponding manhalani 2 plus y siga 5 ka manhalani twice x plus 2 asiga I ka manhale asumna x amso y puto a. Therefore x is 3 and y is 3. Question number 10. Solve the equation for x, y, z and t if this matrix equation asidagi unknown mari si puto haibane. And whether 2 no puri ro 3 no puri ro adding toro we get this. 3 no so right ki the manung element purna makta puri ro. Equating toro badi aikoina first ka 9 ga manha lo twice z minus 3 ka 15 ga manha lo si twice y si ka 12 ka manha lo si twice t plus 6 ka 18 ga manha lo ni. Equation singa sidagi koina x y x की वैल्यू क्या फंगे x की वैल्यू जो 3 फंगे z की वैल्यू जो क्या फंगे z की वैल्यू जो 9 फंगे y की वैल्यू क्या फंगे 6 फंगे t की वैल्यू क्या फंगे 6 फंगे असुम अननोन मरी जो की वैल्यू पुतोय. If x times of this plus y times of this matrix equal to this matrix, find the values of x y. Here x na manung do puri ro y na manung do puri ro ni the sum up toro di si phange equating toro badi x y yaw equation ani phange 1 2 tole equation ani si adding toro si 1 equation 1 plus equation 2 so that y mang kharani adu from the 2x ka thrice x ka di 5x lare ani si 15 lare x na divide toro badi 3 phangani x ki value khange x value khanga badi y ki value equation 1 sinjilo y ki value kaya phange -4 phange y ki value -4 x की वैल्यू 3 y की वैल्यू -4. Question number 12. Given 3 times of this sum of these two matrices, find the values of x, y, z and w. Here 3 times of this matrix apiba si sile apiba si 3 na manung da purira we get this ani si adding toro we get this matrix equating toro badi thrice x ka x plus 4 ka manare thrice y ka si ka x की वैल्यू दो 2 फंगे असुमना thrice y ga siga manhaladi we get y ki value do matang value sinjalak pada 4 phange x y z asumna corresponding thrice z siga manhalaga equation ma phange madu de equation 1 asumna muksu 3 w siga 2 w plus 3 ga manhalaga w ki value 3 phange masi ki value equation 1 da sinjalabadi z ki value 1 phange. Therefore x is 2 y is 4 z is 1 w is 3. Question number 13. F of x is this 3 by 3 matrix so that f of x into f of y equal to f of x plus y. Let us prove. F of x into f of y. F of x na sila ni f of y di x ko di mo y replace tawra ni multiply tawra si first row na first column na puri row we get this first row na second column na puri row we get this first row na third column na puri row we get their sum is 0 Second row na first column that we get this. Second row na second column the purity we get this. Second row na third column the purity we get 0. Assume na third row sina first column the purity 0. Third row sina second column the purity 0. Third row sina third column the purity we get 1. Asi amuk sum up to already. This is the expansion of cos x plus y. This is minus common. This is minus common log that this is sine of x plus y expansion over a. Sin sine of sine of x plus y. See the cos of x plus y. Sin is the purity. Sin is the purity minus. Sin is the purity minus. Sin is the purity minus. Which is equal to f of x plus y. Hanagi x kudumok to x plus y is into a expression. So that this left anigi product right anigi product kamanadi matrix singchi khangjan gadabadi matrix singchi ahan matrix na ani subda leire adu right ta asumna masidi nam line left hand side ki value puthoni product pangthoga right hand side ki product pangthoni ani se manadre. Therefore, left hand side does not equal to right hand side. Assume Roman number 2. To assist left hand side की value product pang to or right hand side की value product pang to or manadre. Therefore, left hand side does not equal to right hand side. Question number 15. A square minus 5a plus 6i if a equal to this. Let us prove left hand side equal to a square have the a into a ni a matrix ani se purina ni minus 5 a की value sinjelo I d kona horen kona I unit matrix identity matrix low c unit matrix of third order ani se product pang to body we get this asuna 5 is the purina body we get this 6 irani I gidi unit matrix of third order have the sin ahan matrix sina 6 the purina matrix ahum is minus plus pang to matung we get this masi phange lastly si phangani. Question number 16. If a equal to this, prove that a cube minus 6a square plus 7a plus twice I equal to 0 matrix tagani prove to haibani. And whether a square meaning the a into a ni a value pishalo a value a matrix sinjala product pang to se phangani. Assume na a cube puto si a into a square ni a value piro a square hojik to phangki butu pishalo product pang to se phangani. Hari ba masak sing chelang chelabadi. Left hand side silasi left hand side की a cube की value piro 6 times of a square plus 7 times of a plus 2 times of I. Makoi simplify to silengan na thamo 6 na puri ro 7 na puri silo 2 na puri silo. Sum up to already we get this. Lastly we get 0 matrix. Sum up phange 0 tare. Hence proof. 17. If a equal to this and I equal to this, find small k so that a square equal to ka minus twice I. A square equal to k times of a minus twice I. A square a into a ni. Adu di a into a di a matrix sing to pishalo k ki dileng na thamo a pishalo 2 pishalo se I ki value pishalo unit matrix second order ki unit matrix. Ani is the product pang thoni k na manung the purishalo 2 na manung the purishalo. Sigin si phange sig sa khai dok na rabadi si phange. Matrix ani se mana rabani equating to rasi equation ama khatang law khatlaga k ki value solve to yarani. K ki value do solve to matam bai koina 1 phange. Question number 19. A trust fund has rupees 30,000 that must be inverted into different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide rupees 30,000 among the two types of bonds if the trust fund must obtain an annual total interest of rupees 1,800 rupees 2,000. Trust amagi 30,000 na do bonds anida invest togadabani. First bond na 5% interest per year ni second bond na 7% interest per year ni. Using matrix multiplication seasonaraga determine how to divide rupees 30,000 among the two types of bonds. Bond makhal ani do 30,000 kalamna distribute togadage if the trust fund must obtain an annual total interest of rupees this. lupa lising ama sanipan lupa lising ani hariba interesting la ko matamda kaya oigedege capital singdu. Let rupees X and rupees 30,000 minus X be the two investments in the two bowls of interest rate 5% and 7% respectively. Then matrix of bowls A na khana C, this is X 30,000 minus X, and matrix of interest rate 5 B na khana C must 5 by 100 7 by 100. Therefore annual interest the product AB na pirani ani sige product pangtho si first row na first column na puriro by question makoi gi interest to lising sani pan orobadi sin sida puribagi value do si tarani equating to rogadi we get this ani se phange sida di x to saman puriro x to solve to si x to lising tranga oran x to lising tranga oradi amadu su 30 dagi x to thokadi sing tranga la thokadi. Thus, the investment in 5% per year is rupees 15,000 and the investment in 7% per year is also rupees 15,000. Animak 15,000 chap manana distribute toroga divide toroga di makoi animak ke lakpa chahi amagi interest to pula punna lising ama sanipan oigen. By question product AB do lising ani lak lagadi karam na divide togan hiyang si. Let us see. Magic ani sige product pang to o madug lising ani ga man halasi. From the X to solve to the listing X na listing manga later. Thus, the investment in 5% and 7% are rupees 5,000 and rupees 25,000 over. Adu already say here with the listing manga listing ani lani. Question number 18. If A equal to this and I is the identity matrix of order 2, so that I plus A equal to I minus A times of cos alpha minus sin alpha by sin alpha cos alpha. Let us prove. I plus A. I is this, A is this. Their sum up is this. Mapamasi the theta sina alpha by 2 bukangarasi. So the left hand side putokre, also right hand side putoksi I plus A. I minus A the sipangani. Aduga api bodosi the alpha na theta equal to alpha by 2 already. Alpha haibasi kayaga manare. Alpha haibasi twice theta ka manare. Cos twice theta in terms of 10 sini sin twice theta in terms of 10 theta the sini makoi sim the value pisele multiply to the first row na first column da and sum up we get this. First row na second column da corresponding purinara sum up to already we get this. Assume na second row na first column da puriro we get this. Second row sina second column da puriro and sum up we get this. Sum up torobadi mataki han bagisina 1 lerani mathangi cd minus 10 theta lerani sigisu 10 theta lerani c 1 lerani masi right ani se manare right ani se manarabanina left ani se manare hence proof. Question number 20. The books of a particular school has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books. Their selling prices are rupees 80, rupees 60 and rupees 40 each respectively. Find the total amount the bookshop will receive from selling all the books using matrix algebra. Particular school namagi bookshop like dukan da 10 dozen chemistry books like 8 dozen physics books like 10 dozen economic books like their selling prices are rupees 80, 60, 40 respectively. Makoigi like amagi mamansi rupees 80, rupees 60, rupees 40 ore. Mathang sitna. Find the total amount the bookshop will receive from selling all the books using matrix algebra. Makona like sing the loni yontok kiba matanda pangakado upon amount to kayano matrix algebra seasonaraga putu heaven. The matrix of number of books A dozen tara dozen number the like item trying to everybody dozen taragi di 10 into 12 ni dozen nipangi di 8 into 12 ni dozen taragi di amuk 10 into 12 ni shina matrix of number of books ni that is 120 96 120. The matrix of selling prices B D like amag like maman like masing asiga like amagi maman ga khangna rabo ani digo prayer pangtho obadi aikoina makoige hariba like sing sige apun post price to phangakadrevani. That is we get this. Therefore total amount of the books of the makoina phangadabe amount of the product A B ni sinista purira we get this number since sum up torosi si phange. Therefore total amount rupees 20,160 oran. Choose the correct answer in exercise 21 and 22. Assume X, Y, Z, W, and P are matrices so order 2 by N, 3 by K, 2 by P, N by 3, P by K respectively. The restriction on N, K, and P so that P, Y plus W, Y will be defined are. Let us try. The orders of P, W, Y are P gidi kaya pyramid, P gidi P by K pyramid, W gidi kaya pyramid, W gidi N by 3 pyramid, Y gidi kaya pyramid, Y gidi 3 by K pyramid. The order of PY is P by K. PY gidi P ga Y gidi P ga Y gidi order the PK when K equal to 3. The order of WY is NK. WY gidi W go Y gidi mabani gidi N by K oirani. Therefore mabani adding to is defined if mabani se adding to ge hairabadi PY ga WY ga ani se tinsinaba yahan ge hairabadi tinsinaba yahan ge P ge N ga manaba tare. Correct answer is K gi value 3 oiraga P ge N ga manarabadi si define togani. Correct answer is option A. If n equal to p, then the order of the matrices this is n p ga manarabadi 7x minus 5. The order of x and z are 2 by n and 2 by p. Mathakta yahaure question number 21 da. Now p equal to n asima pyramid. Order of 7x minus 5z is 2 by n orani. Thus answer is B.